I'm live. Yes, we are live. Let me mute my mic. All right. You got Bye Bye there in the background. My thumbnail! I put a lot of work in that thumbnail. Why is it not showing up? Show my goddamn thumbnail. That is a masterpiece of art. It's still showing my old shitty ass one. I spent like 20 minutes on that. Here, I'm gonna make sure it's working. Yeah, they didn't fucking change it. What the hell? I'm the best programmer on earth. Yes, save. We had trouble saving your video. Retrying in 5 seconds. Please? Whoa. We couldn't update your video. Okay, can I change it to this? That works, but the best programmer on earth doesn't work. Change to save. Oh my god, did it work? Come on, please. Oh, please. For me. Come on. You know you want to. Come on. We couldn't update your video. Why? I put so much work into that thumbnail. Why is it just not working? I'm the best programmer on earth. Why is it not working? Here. Okay, this is so annoying. I'm gonna try to take a screenshot of it. Maybe the resolution's too high. Alright, we're opening this up in GIMP. I'm fixing this. I put a lot of work in that thumbnail. File corrupt? What do you mean file corrupted? What do you mean file corrupted? Where are all the files corrupted? So it can open these, but it can't open this one. Why? YouTube was able to see it. View, show me. Oh, preview not available. Uncorrupt PNG. What the hell? It's not working. This better work. I put so much work in this thumbnail. No success. As it showed me a preview of it. It actually showed me a preview of the image it failed to recover. This is ridiculous. Okay. Okay, we need preview PNG. Come on, give me preview a PNG. I need to just do this. I put so much work in this thumbnail just for it to not work. Alright, yes. Taking a screen. Download the new one. Just download it. I'm not. You want me to pay a subscription to download a PNG? Bro, what is your problem? Okay, let's open the output in GIMP. This is supposed to be a programming stream. Okay, for some reason it's got this white like border on the bottom. It's the best thumbnail ever. There we go. This is it. Oh, I didn't wait for this to be done. No, but look. My eyes, these used to be glowing. Here. Can I fix it? If I do new from visible. Oh, whatever, it's fine. Whatever. Whatever. Move my goddamn camera away. It's best to. Does this work? Yes! It worked! We did it. Okay. God, that took way too long. Shout out to GIMP for corrupting my thumbnail. Anyway. Alright. Anyway. What we're actually here for. We're working on the terrain generator. For my Minecraft recreation of the terrain generator for the Nether Star. Specifically work on the carvers. So, if you go to draw.io, you can sort of see what I have finished already, which is a lot. Over here is what I need and what we have. Oh, okay, Lifo just teleported me down. Over here is what we need and what we have. So we don't need initialize light, spawn, or full. These are all mobs and rendering. Don't care. Surface, we don't care what the blocks are. Structure references. Structures are stored on a global grid. We couldn't care. And empty, obviously, we're not going to worry about that. So, what we need to worry about right now are these two. Specifically the first one. We're doing carvers today. So, as it currently stands, we have structure starts, biomes, and the noise done. We need to implement the carvers, which are what create those, like a worm going through an apple type caves, and then futures, which are like trees in a biome, or the fucking spires, annoying little fucking spires in a basalt delta. But everything else is finished. So yeah, I also do have a basic visualizer. It's not working right now because the code won't compile, obviously. But we are now working on that. So here we are in Chunk Generator, and we're working on apply carvers. Now what we are trying to do is we're trying to get some chunk data by getting chunks around the chunk that we're in. And we get that by referencing the position. If we look here at apply carvers, in the Java, which the Nether uses the noise-based chunk generator, so we're gonna reference this. You can see here we get the chunk position, then we get a chunk axis. So we do world gen region being world gen region dot get chunk, and what this dot get chunk ij chunk status dot empty. All right, so maybe it's looking for a chunk that's empty, I think, unless we specify. And if I remember correctly, this is must exist. So can return null. So get chunk can return null. So what it does is this dot has chunk at these coordinates, which are x and z, minus this dot first pos dot x, What's that? Origin region. Right radius cutoff. Cache size is not square. Right, so things are relative to some first chunk. Right. We don't really care about that. Right. So this set has chunk XZ. So these are local coordinates, I believe. X, take away this dot first. So this is, yeah, so these are local X. So this is, unless this would be local Z. So it's getting the coordinates and it's making them local relative to the first chunk of the gen region. Then we do this dot cache dot get local X plus local Z times this dot size. That looks like a bit, that looks like a, what's it called, a bitmap? What are you? A list of chunk access. So it's a list. So local X plus local Z times this dot size on a get. And this is, okay, this is just Java, so it's a list. So I'm guessing get is like get at an index. And chunk access is chunk access. So we do this dot cache dot. So it's encoding them. Encodes chunks in a flat list, like this. That's interesting. That's an interesting way to do things. So we do if chunk access dot get status. That is or after. What is or after here? This dot get index is greater than chunk status dot get index. So if it's is or after chunk status, return it. Interesting. So what it looks like it's doing is it's basically it's storing all the data in a list. I think we can get away with not doing that. I think so. I already implemented some of this. We have it implemented in a world file, which is basically a catch-all, everything related to global state, including chunks. Chunks are stored as a hash map between chunk pos and chunk access data. That's all we really care about. So let's re-implement what they have. So public function get chunk, and we want to take in the world. And we want to output a immutable reference to chunk access data. It just depends on what they want. Because it's a reference, we need to specify the lifetime of it. So, oh yeah. Then we need, let's just do for now must exist. That will be a boolean. Alright, and we basically what we'll do is we'll say we need a position. So we'll do chunk pos. And nothing is relative here. Everything is global, which makes things a lot easier. So what we could just say is we could just look at the map. So we could say chunk opt for optional equals world dot chunks dot get and the chunk position. And we can do if let some chunk equals chunk opt. Do we want to return it? Oh, but there was a problem. This could be optional. Right, so we want to make this optional because it could not exist, right? So we want to return some. Else. So in this case, the chunk isn't found. We need to check if must exist. So if must exist, then panic attempt to get chunk not found must exist flag is true. Else, then we just want to return none. Explicit lifetime required in the type world. Oh yeah. This is basically saying is that while world exists, the chunk access will exist. It's telling the compiler chunk access and world, the two structs have some sort of connection to each other. God bless lifetimes. Might be the first Rust programmer to say that. Okay. What's next? This would apply for things in a straight line. Look at this. This implies everything's in a straight line. X is greater than first pause, and X is less than last pause. And Z is greater than first pause and less than last pause. That sort of implies that it's like diagonal. Like you have two corners. What is world gen region exactly supposed to be then? Let's go apply carvers and see how it uses it. What's the chunk status? I'm confused. So origin region stores an area of chunks. We don't need to do that. We can access them directly. If we accept that Carver generation cannot be multi-threaded. That's the trade-off. Or we can implement origin region and have it, because we would have to act on multiple chunks. I do really want it to be multi-threaded. I mean, it's gonna take a really long time. I estimate already, just with noise generation, my computer's gonna be on for at least 4 hours, if not more, just generating chunks during the pathfinding. Ooh, it's 4 hours more. I don't think that's a huge priority, though. So, the generator is already expecting those chunks to exist. The origin region is created before. So, before we do that, we need to tell the world, ensure these chunks are generated. Thank you. Right? So we need to do that. So we need to specify a center chunk and a radius where the world is responsible for saying, "Hey, I got you. No worries, my man. I will make sure these chunks are up to snuff. They're generated, you know." Okay, let's make that. I think that's a good step now. But to do that, we also have to implement generating a chunk. Chunks. If I go to chunk access, right? This is chunk access. It's 35 lines. We need to store the chunk generation step. How close is it to being done? Okay. What steps do we have? Okay, let's create an enum. Chunk generation step. So we have, it starts out as empty. Then we do structure finding. Let's do structure finding. Structure finding. Then after that, we want to do noise. Then we want to do carvers. Then features. Then finished. Step, that'll be chunk generation step. Why would I need to clone chunk access data? That should never happen. Why did I add that? What was I thinking when I typed that? What the fuck? No, I should never be able to clone a chunk. It's ridiculous. So I think it's who orchestrates chunk generation? Who actually generates the chunks? Who's responsible for saying, hey, okay, so we know chunk generator. Chunk generator has all the steps. Chunk generator, whoops, I don't know, how, what did I just do? I closed everything except for chunk generator? How did I do that? Literally, how did that happen? Wow, okay. That's annoying. Anyway, chunk generator is responsible for all the steps. Like, it has the step for apply carvers, find nearest map structure, get nearest generated structure, get structure generating at, those are helpers, apply biome decoration, that's a real one, build surface, you know, get all structures, create structures, try generate structure, fetch references, create references. All of these are functions that dictate how the chunk generates. But my question is, who's orchestrating this? Like, we have all the functions that are responsible for making a chunk a chunk. Who's the guy saying, okay, chunk, you do this, then do that, then do that? Who's the guy orchestrating the chunk generator? I have a suspicion it's the chunk itself. I think proto chunk, because proto chunk is by definition a chunk that isn't done generating. None of these about generation. Who does the generating? Why is so low quality on YouTube? Oh, I had the quality down. That's probably why. That's low quality. Set chunk status. That's my goal. When you're done generating something, you have to set the chunk status. So whoever sets the chunk status likely has some generation going on, or is tied to has to be, by definition, has to be tied to some generation. So let's see if we could follow that. Set status. Chunk status calls this. Imposter proto chunk calls this. And chunk serializer. So, chunk serializer. Chunk serializer saves chunks to storage. Probably not important. Imposter proto chunk is a real chunk, a finished level chunk pertaining to be a proto chunk. Probably not. Chunk status. Could be. Could be. Ah. Here we go. Do work. Okay. JVM profile. Wow. Completable future. Generate. We found it. We found it. We found it. It's called generate. It's called generate. Chunk axis is list dot get list size out of a 2. Profile duration equals. We don't care. We don't care about that. Return this dot generation task. Okay, what is generation task? Dot do work. Passing in server level a bunch of stuff. Then apply either if left chunk axis it's just a proto chunk and proto chunk to get status that is or after this. So and what this is saying is if proto chunk, if its current status is greater than this current status, then don't do anything. So it's basically saying like the status is this the chunk generation step. If it's on noise and the generator is on structure finding is less than noise, so it'll increase it. But if it's on carvers and it's generating noise for some reason, then there's a lot of it's mostly the same, but from what I can tell from the source code, Minecraft isn't strictly following this. It goes back the structures for the room portal and the nether fossils, for example, generate noise. So it goes back and forth a lot. And so if it's like noise and it's doing structure finding, it won't go forward. That's what this is saying. But what does do work? What does do work here? Interface. Do work. One implementation. It's not. Here we go. Here we go. So we have in biomes in full initialize light, noise, structure starts, and then we have simple generation task. What's this? This dot do work. Is this implemented anywhere? I don't think it is. Okay, so we're not worried about that one. Why are there so many structure starts though? Okay, so let's go back to generate. Who do we think it is? So carvers, do carvers have a generation step? They should. Let's look at full. That's disgusting. Carvers. So this is so okay. These are the functions. Okay, I think I figured it out. So it's empty, and we can check chunk types, chunk status. Oh, these are the wait, are these chunk status? It's a class. Okay, I'm not very familiar with Java, so it's empty, structure starts, then structure references, then biomes, then noise, then surface, then carvers, then futures, initialize light, and that all checks out. It's empty, structure start, structure references, biomes, noise, surface, carvers, futures, and then we do the light. This all perfectly fits in. So this is the generator. Right here. This is it. Okay. Okay, so this brings us to a pretty a problem. If we do this, what happens is go to the carvers. Make sure I'm not private on my stream again. Good. Not again. What happens is carvers they create a world gen region with the chunk status. And then it applies carvers to it. There's a problem. This can get applied to multiple of them. What is I in this? Right radius cut off. So this would cause a loop, though. What happens is one chunk wants 8 chunks around it, right, to do carving. But then one of those 8 chunks, it also wants to do carving. So it needs 8 chunks around it, and then it causes an infinite loop. Or eventually there's a million chunks just generating. Because they all want chunks around them to do carving. There's always going to be an edge. So how do they solve that? Okay. Alright. So here's what we're gonna do. Okay. I thought about this. Here's the plan. There are multiple stages of chunk generation, as we know. What we need to do is, and because if we generate to carvers, it's not going to go too well. So what we can do is we can have a command that generates it up to a point, right? So let's do that. Let's do generate to step, and the step is good. We need a mutable. We need the chunk access data. And this music around. And the step. The step is going to be. How do you convert Rust? Convert enum to number. Can I do that? Yeah, we could just do as use size. So we could set let numbered step equal step as use size. And what we need to do is do if numbered step is greater than chunk data dot step dot as use size. If that's the case, then we can just return, and we can print, like, it's not we don't want to crash, but it is a concern, so we'll just print I'll do warn attempt to generate chunk to step it is above or equal to, is below or equal to, and we want to do that. Okay, so now we need to figure out what it's at. So we need to know what step we are at. So we need to match. So we need to figure out, so we need to do generate step. We need the chunk data and we need the step. This generates not to the step, but the step, right? And this will, yeah, this will just modify it. And what we could say is generate step. We need to match step. And we first need to check, like, if chunk data dot step is doesn't equal step -1, and we want to do as use size. Then I think we should panic, actually. Attempt to call generate step on invalid step sequence. Okay, we can match step now. Not exhaustive. So if we're trying to do empty, we could just return if we're trying to do empty, right? If we're on empty, we could just say chunk data. Let's create another function. Advance step No, we don't need another function to do that, do we? No, I think it's a helper function. We could just say chunk data dot step let step let numbered step for chunk data dot step as usize. Let next step equal numbered step plus 1. Can we just do as chunk access data? Does that work? Inf. Drive enum partial. Oh, there's okay. There's. Okay, that might not be possible without a library. I'm just gonna match. I'm gonna be so free with you. So match numbered step plus 1. Okay, so 0 is going to equal empty. 1 is going to it's going to be structure finding. Can I make it equal a match? God, we fucking love Rust. All right. Anyways, so generate step. We just want to say chunk. We just want to say advanced step. Chunk data. And we always want to do that. So let's not have it. No, we'll put it in there. Why not? Next, we want to do structure finding. So we want to say chunk generator colon create structures. We want chunk generator data. What is chunk generator data? Forget. The seed, the biome source, and the settings. We'll just do import chunk generator data public from default and then return self. We'll say self and seed is equal to the constant seed biome source biome source. What are you? You know what? I have no idea why you need that, but I guess I could give it to you. Let's do climate, colon, from nether, seed. Settings, this will be just be nether noise settings. We'll just say let chunk generator data equal chunk generator colon chunk generator data colon from default. Okay, we pass in chunk generator data. Define it as mutable. And now we need to advance step. After that, it's going to be, I believe, noise is after that. It is. Handle noise, chunk generator, data, colon. Do we have... We don't have that yet. Let's add that. I already have that basically done. So we're going to do pub function generate noise. And this is gonna for the chunk. So we need to get the data and the chunk data. And for the chunk we need to specify the blocks. How many blocks are there going to be? Okay, here we're going to represent blocks as a bit set. I have the bit set crate installed. And this is basically just a series of zeros and ones. How many is there going to be? So 16 times 16 times 16 times 128. 32,768. So we'll just do check X data public function new. So return self. Okay, then we can say self structure starts equals hash map structure starts equals hash map colon new. Pause. Oh, we do need that. We need to know what position. So we'll say pause is going to be type chunk pause. Oh, actually, these are just the same. The step is going to be empty. And the block is going to equal a bit set colon with capacity. How many bits? Let me go back here. So it's 16 times 16 times the 128. That's going to be 32768. So that is going to be the maximum amount of blocks that could fit inside of a chunk. And so what we need to do is we also, I'm going to quickly comment this out. I'm getting this error. We want to set block. Mutable reference to self, rare. For a block pause. Now what we're going to do is we're going to say self.bitset dot, hold on, I'm going to rename this to blocks dot blocks dot we want to set an insert, yeah. So we add an integer. How do we uniquely hash this? We can't just add up the numbers. Oh, my power's low. charging? Yes. So we need to hash it. So we need to say hash vector hash block pause. I'm just gonna copy this over. I don't know anything about hashing, sorry. I'm not. Hold on. So what this is doing is we're hashing it into a long with no collisions. Oh my god. God, look at this dork. I'm so cool for knowing quantum mechanics. This fucking loser. Okay. Where was I? Do I just add these together? Oh, no. I do. But, cool. Thanks. Anyways, have fun, Dorkfest Nerd Squad. What the fuck did I do? Okay. Just itself. This is going to turn a bool. I like that block sounds better there. I need a mutable reference. You need a mutable reference. Okay. So now we have a list of block positions. So we need to go through the chunk. Okay, so we need a 4x and -8 and 0 to 16. For z in 0 to 16. And for y in 0 to 128. So this is every block in the chunk. We need to first define, we need to find a cache. This is the interpolation cache. Minecraft keeps track of, Minecraft doesn't generate every block. That'd be way too expensive. Instead, it generates, like, it generates some blocks, and then it does trilinear interpolation between them. So, it took me a while to figure out. And so the block result is going to equal, yeah, let block result equal nether, is it called nether functions, : compute block exists. And so this function, it's significantly shorter than how Minecraft does it, but what it's doing is it's basically a front for the entire pipeline. It runs compute the nether. And compute the nether, this is the function. This is the function that computes if the nether computes the blocks of the nether. So this function gets us 99% of the way there to full parity. But for now, we don't need that. And the cache, the cache is storing blocks that it's storing the corners that I talked about that it's already checked, so it doesn't have to regenerate them. The interpolation is sort of like a trade-off. The first few ones are more expensive because you have to generate all 8 corners, but after that it gets significantly cheaper, so it's a good trade-off for lots of stuff. And so block result is is there a block there, and so we need to encode it. No, we don't. The encoding is handled by the chunk. So we do chunk dot add block. We just need to check if block result, then chunk dot add block at the position. In the position, okay, let's define this outside here then. Let pause equal this. We'll define pause in here. We'll make this a reference. You don't need that. I don't think you need that either. Make this a reference. There's no reason. No, you do need that actually. Okay. Well, block pause implements clone or copy, so it's not a big deal. But that is annoying. And this is it. What is this, like a little bit more than 10 lines of code? This is the generator for the entirety of the nether. So, I mean, it's a very high level overview of it. It goes deep. It goes deep. I like the majority of these programs. Oh my god. There's so many files in the repository. The majority of this is for this function right here. So, it's you know, great functions are built on the shoulders of good giant functions. There we go. And we could just go to the chunk axis and we'll say, if we're on noise, then we'll say chunk generator, generate noise. Data is going to be the chunk generator data. Then chunk is always going to be chunk data, and then we can do advanced step. Okay, what's next? After noise, we have chunk generator carvers. hey, we're working on that right now. So we do chunk generator, colon, apply carvers, and we'll just pass in the chunk. We'll do advanced step. And everything else isn't implemented yet. So we'll say, we'll just print not yet implemented. Step, and we'll say, this is not yet implemented. And we'll say step dot step. Can we do that? It needs to implement debug. Let's implement debug. All right. That was actually pretty quick. I do need to go to the bathroom though. I'll be right with you. I'll be right back. I'm back. It still shows me not bad. Okay, let's do this now. Let's change the music up a bit. Listen. I'm all for bye bye there, but you know we can mix things up. We can change things. So is life, you know. Not everything is always going to be the same. Quote me. I could just add it to my fstab or my fs tab. You see, I always pronounced it fstab, but fs tab makes much more sense. But I prefer fstab. I think fstab sounds cooler. I could just add it to my fstab, but I won't because I'm lazy. Like, I really should have done it a long time ago. I don't think I've had this server for like a few months, but I've just never added it to my fstab. Where is it? I think it's in, no, it's in music, stuff, no, editing, here it is. Ah. God, I love this music. Thank you, Marigold. Okay, so we need to go to world. Oh, we need to do get chunk or generate up to. And we actually do need to check that. I don't think I implemented generate up to. Yeah, I didn't. Is this, hold on, what is that? So what this is doing, wow, this is really loud. Quiet it down a bit. So what this is doing is it's saying for every step in between our current step and desired step, including desired step, but not including our current step, because we don't want to generate ourselves twice. Let me make this function. I know, I'll make this a function of the enum. Okay, so now we have the actual step. Then we can just do generate step. And then our step. There we go. This seems so much simpler. Dude, I'm glad. I'm past, right now, I'm past the low level grunt work. I'm past that, which is, I'm so glad. This is sort of super fit. Like, I don't even have to implement the carvers, because all I do is delete stuff, as far as I'm aware. So, like, for all intents and purposes, I'm pretty much already done. But, yeah. But this is actually super easy. Like, it's only 136 lines of code. The amount of simplification I've done is insane. My goal is simplification without, like, an obsessive compromise. And I think I've done that. Only exception might be the Bastion Remnants, because those just have a big bounding box instead of, you know, jigsawing the rooms. But I'm not suicidal, so I'm not going to go through all the MBT and write that data down. So I don't, like, I might write a parser to do that at the end of the project if I really feel like that's important. But I don't see that as a huge priority. And then, of course, for optimization, I'm using Rayon, I think it's called, to do things optimized. Right? Optimized generation. Pretty cool and great, I would suspect. You know, let's do a little bit of premature optimization. Why not? I'm feeling cool today. So we have this. We can do in 0 to 128 dot, and if we go ahead and we include rayon in here, rayon colon prelude colon asterisk dot pair into pair iter dot. We just want to do dot for each, right? Is for, yeah, for each. And so we need to define the y, and then we're just gonna do this. Okay. Now there's an issue. Cache. Ooh, that's a problem. That's a problem. We need to define them. I want to define it for each. Ooh. Maybe not. Maybe it's not a good idea to put that here. Never mind. We'll put that in the actual, like, the area where chunks are actually properly generated. I think we'll have the chunks themselves be generated threadedly, but like the actual like noise for the chunk being built single-threaded, but the chunks themselves will be multi-threaded. Like the world generator will spread the load across all 6 cores of my machine. And I'll get rid of generate here. That's not gonna go here. Dude, I love. This is a song of freedom and captivity. Okay, so if there's already a chunk, you know, that's pretty goated. We'll just go ahead and return it. So it's going to return a reference to a chunk access data, and it's always going to do that, right? Because if it doesn't find it, it's going to make it. So it's always going to be doing that. But we need to make sure that it's above that. So, okay, so we do if chunk dot step is less than the step Yeah, this is pretty much always going to be mutable. I can't think of a situation where we don't want a mutable reference. Lifetime must precede mute. Oh, sorry. I'm sorry, Mr. Compiler. Mr. Get Mute instead of Get. Which means we need you to be mutable. We love mutability here. Okay, so what this is doing is basically we're checking if there's a chunk, and if there is a chunk, we're checking is the chunk's step too low. Basically, is it below what we want it to be? If it is, then we order it to generate up to where it needs to be, and then we return it. If it's not, then we go ahead and return it. If there's not a chunk, we have to make a chunk. Okay. Oops. Immutable effort. What's missing type of function? World ship snake case name. It's the destruct. What are you saying? Oh, it must precede me. I just made that mistake. Why am what am I doing, bro? Okay, so we generate up to step, and then we want to return it. But to do that, we want to first insert it. So we want to do add chunk. Do we have an add chunk? We do not. So we need a key, which is a position. So we'll just do chunk dot position and then chunk. There we go. Inserted, completed. Ayo. I'm sorry. We haven't returned the index. Why not? That'll just make things easier. Oh, it's not an index. Yeah. It's not index based. Okay, never mind. Sorry, I'm so used to doing index based stuff. Generate to step, and then we want to return the chunk. So I will do get chunk world We'll do a dot unwrap. It has its own error message. That's pretty self-explanatory. I would just do expect error occurred in get chunk during up to, because this it'll print an error message if something goes wrong, and then it'll basically just get forwarded up to here. I think it prints this as well. Cannot borrow mute. Okay. This is the first time we've got a borrow checker error in a long time. So this is a mutable borrow to get this chunk. Okay, we only need that here, so can I just, if I put you here, do you behave? Because this one, we mutably, okay, so else, put you in an else clause. Right, you're mutably borrowed, but there shouldn't be more than one at a time. Right, because you do get chunk. Right. So chunk is defined here in scope. World is barred for A. So the issue is that we're borrowing it here. But I want to drop that borrow if it doesn't follow through. I thought that was already here. How do I drop? So I'm doing this get chunk. So I'm mutably borrowing it. But either way, we return out of the function with that. Then we shouldn't have like chunk should be a dead variable. Yeah, chunk, I don't have access to it. And this is defined here. Okay, what if we create a function called hasChunk? Where it only needs to borrow like it immutably, and that returns a bool. Yes, I think this should work. Yes. I'm so sorry for doing that. Okay, now we need to do allocate space up to. Okay, so we need the chunk pause. This is going to be the origin. Radius is going to be an let's do an I8, a U8. Doesn't need to be a huge value. That covers at 255. There's no chance we're generating more than 255 chunks at a time. Alright, and we need an immutable or immutable reference to world. Okay. And we need to know what we're generating up to. So this is going to effectively be like what generates the chunks. So what we need to do okay. Let's do this. So we need to create a loop that starts at the origin, goes up and left. Okay, so we need to say for x let's define some variables. Let start x equal origin dot x, take away radius. You know, it'd probably be easier if we just make this I3 too, so we don't have to do a bunch of conversions. So origin x, take away radius, that's the starting x. Let's start y equal origin dot y, origin z, take away radius. So this is the start position. Right. Do for x in start x to start x plus, let's do end x as well. We want to take all these positions and map them. So we want to say let chunk positions equals, and this is going to be a vector of chunk positions. And then we're going to create another vector of, no, because then we would need to do immutable. How do we do this where we don't have to do immutable borrow? Or immutable, yeah. Okay, so you want to go through each one and check generate list, a list that needs to be generated. So we need to do get chunk is generated up to. Okay. If there is a chunk, we want to do true. No, we want to get a chunk and we're just gonna say, hey, are you generated up to this point? So it's gonna be bool. And we don't want to generate a new one. We want to say if has chunk. If the chunk, and if it's less than, then false. Else true. Whoa. And if there is no chunk, then we want to do false. Okay, let's do get chunk immutable. Okay, we have a generate list. These are chunks that need to be generated, and an update list are chunks that need to be updated. No, that's evil. Okay, now we. Okay, now. Sorry, that's wrong. That's wrong. We need to check. Does the chunk exist? So we do let does chunk exist equal get chunk generated up to the world, the chunk pause. So we say let chunk pause equal chunk pause. Does it have colon new? It does not. Let's just do x and z. So does chunk. Okay, we'll do let does chunk exist equal has chunk. And we'll basically just do if it doesn't have that. So if not does chunk exist, then just continue. Then we want to do generate list dot push this does chunk exist, or the chunk pause. Wait a minute, make sure these are both mutable. Is chunk updated? I want to do if not is chunk updated. Then we want to do update list dot push chunk pause. So now we have a list of chunks that we need to update and a list of chunks that we need to generate. So first, let's go through the update list. So we want to do update list dot par iter dot for each and dot map actually. So we want to produce a new list. So we say pause and we could just do iter into par iter. It doesn't matter. They're chunk positions, and we're not going to need this after, so we might as well free up the memory. Okay. So what this is basically doing is going through each one, and it's using it to build a new list. So in here, basically, we need to update it. So we need to get the chunk from the chunk position, which means that we do need the chunk access data. Fuck. Okay. We need a mutable reference to it. But doing this would mean that we would have more than one mutable reference to world. So we might not be able to update multi-threadedly. That would be especially bad if they didn't have noise, but that's very unlikely. Ooh, that's... We can try. Let me try. Get chunk is generated. We want to get the chunk. World chunk position must exist. Is true. Dot expect. Did it work? Yes. Yes, no, it didn't work. That's what I was expecting. Try. See, because we do this, then later in the loop, the issue is that we get the chunk, it's a mutable borrow. So this can't really exist. Okay, to make things simpler, honestly, I think the plan, the high-tech plan is we literally just make updating single-threaded. And for here, we just do iter. So for every pause, we say let chunk equal get chunk. And we need to do chunk access. Go on. Generate two-step chunk data is going to be chunk to step, and what do we want to do with this? Nothing. We just want to remove it. We just want to delete it. Dot for each. Why am I getting an error? Okay, now we want to do generate list. This time we really want to be able to do this parallel, because almost certainly it hasn't reached noise generation yet. Well, because it doesn't, because it hasn't been generated. So pause. And what we want to do is we don't want to do for each, we want to do map. That's what this is going to do. This is going to map it. We could do into iter. We can map a new list with this. So we need to go through each one, and we need to generate. So we need to say let chunk equal chunk access colon new for the pause. And we need to say chunk access, on generate to step, chunk, step, and we want to return chunk dot collect. And what is this going to return? It's going to return a bunch of chunks, so we just want to get dot collect, and we want to say let new generated chunks equals, and this is going to be a vector of chunk access datas. All right, and then we have all these chunk access. Ooh, we have an issue. Oh yeah, we have all these newly generated chunks, and we want to do newly generated chunks dot intuiter, and we want for each we want to add it to the hash map with the position. So we'll say world dot chunks dot push or dot insert. The key is going to be chunk dot pause and chunk. Alright, I think I'm going to end the stream here. I've been streaming for longer than I have my other two ones, so hopefully this was entertaining and you learned.